In this video, we'll be talking about different kinds of frequency tables and how to create frequency tables. I'll go ahead and share my screen with you and we'll get started. When we're talking about visualizing data with tables and graphs, the first question that we have to ask is, why do we use tables and graphs? Why are these important to begin with? And the fact is that tables and graphs can help summarize our data by giving an organized way to view data quickly and efficiently and to be able to see if there are any patterns in the data. Figures and tables can show us the shape of our distribution, the most frequent score, whether there are outliers or not. And if we're trying to compare different groups statistically, we can start by visually comparing our groups using graphs. And this is why it's really so important, regardless of what kind of analysis we're doing, to always make sure that we have a table or graph to begin with. That's usually the first step that we'll take before we even analyze our data, is to create some kind of table or graph so that we can visualize our data. As we start talking about frequency and frequency tables, the first question that we'll have is, what is frequency? And if you look up the dictionary definition of frequency, it's the rate at which something occurs or is repeated over a particular period of time. Our definition is going to be the number of scores with a particular value. So again, it's the number of times something occurs, the number of times that something is repeated, and particularly it's the number of different scores with a particular value. And so our frequency table is going to show how many times each score occurred. We're going to have 4 steps for making a frequency table. And so we'll walk through these steps and then we'll go step by step with an example. And so for step 1, we're going to list each possible value from lowest to highest. And it's important that we list each possible value, not just the values that we have in our data set, but each possible value for our measurement. And we'll get to that again in just a little bit. For step 2, we're going to go one by one through our scores and make a tally mark for each score next to its value on the list. Step 3, we're going to make a table showing how many times each value on our list was used. And step 4, we're going to figure out the percentages of scores for each value. And so we're actually going to use a different data set than I had on the last slide, so I'll skip past that. But for step 1, in this example, our research study used a happiness scale that ranged from 0, meaning our participant was not at all happy, to 10, meaning our participant was extremely happy. And so for step 1, we're going to list each possible value from lowest to highest. And so we're going to have our values here from 0 to 10. And again, we're not even looking at our scores yet. We're just listing every possible value, whether or not it was used, whether or not a participant actually ever gave the rating. Doesn't matter, listing every possible value here. For step 2, we're going to go one by one through the scores that we have here. These are the data that our participants have given us. And we're going to make a tally mark next to each value on the list. So for instance, my first number here is number 8. And so I'll go next to that happiness rating of 8 and make a tally mark here, which we can see. Next score is 2. So I'll go to that happiness rating of 2, make a tally mark in that next column next to the 2. And we can see that if we just keep doing that, our final product is what we have here. So we have, for instance, 3 tally marks next to the number 1 for that happiness rating of 1. And that means that I have 3 scores in my data set here that gave a rating of 1 for my happiness score. And again, we can see that there's no tally marks in the 0 or the 10 for those 2 values. And that's because we don't have scores of 0 or 10, but we still have those values represented in that first column, because in step 1, we want all possible values, whether or not there is a score for that value. For step 3, now we're going to just add the number, the numeral there of how many tallies we have, and that's going to be our frequency. And so we don't have any tally marks for that happiness rating of 0, and so the frequency there will be 0. We have 3 tally marks for the happiness rating of 1, and so our frequency will be 3, and so on and so on. And now our last step is just going to be just a teeny bit more involved, but it's going to be very straightforward. We have these step-by-step instructions here. We're going to calculate the percentage of scores for each value. And so to do this, we're going to take the frequency of a particular value. We're going to divide that by the total number of scores. And then we're going to take that answer and we're going to multiply it by 100. And so, for example, we have 4 participants who rated their happiness at a level of 3, which if I go back here, we can see that that is the case. If we go to happiness rating of 3, we have frequency of 4 there. So 4 participants rated their happiness at a level of 3. To calculate the percent, we're going to take that 4, divide it by the total number of scores, which is 20 scores if we count up the number of scores that we have here. And if I do this just on a calculator quick, I have 4 divided by 20, and I get 0.20. And then we're going to multiply that by 100, which if I do that, we're going to get 20. And so when we go to this next slide, we can see for a happiness rating of 3, our frequency is 4, and the percentage there is 20. And we're going to do that for every single value. And so this is what our completed frequency table will look like. And you'll notice kind of going from step 3 to step 4, I've actually taken out that frequency tally column. We really don't need that. We can think of our frequency column as replacing that. The tally column is really just kind of the work that we do in order to produce the frequency, and then we can calculate the percentage from there. And so we can put those tallies on the side if we want. We can erase that column if you want. You can even leave it in if you want. Generally, that would be just fine, at least for the purposes of our class. If you're putting this into a paper or something, you'd want to get rid of that. But so you can have either these 3 columns, or you can all have 4 columns, including that tally column. And that's our completed frequency table. There are other kinds of frequency tables as well, and so we'll go over these quickly as well. But for each frequency table, each type of frequency table, the instructions are really just the same. They're going to be different in very, very slight ways. These are all variations on the same theme. And so, for instance, this is an example of a completed frequency table for a nominal variable. And in this case, our nominal or our categorical variable here is major. And so you can see that the only difference here really is that we're going to have, instead of now numbers as our possible values, here we're having these different majors: psychology, sociology, anthropology, political science in this case. And so now we have names of categories, or these names of these groups, rather than numbers. But we're still going to tally the number of times that a particular name or category was selected. We're still going to write in the numerical number of the frequency that we got from those tally marks. We're still going to calculate the percentage the exact same way. And so all of the steps are going to be the same. It's just that now we're working with names of categories or groups instead of numbers. And lastly, we have a grouped frequency table. And so in this particular case, with a grouped frequency table, this is just a normal frequency table, but instead of having individual values for that possible values column, we're going to use a group of values. And specifically, we're going to talk about an interval of values. And so, for instance, we can have possible values ranging from 1 to 10, and we can have intervals of, for instance, 1 to 2, 3 to 4, 5 to 6, and so on. And so in this case, the interval would be 2, which means that there are 2 scores grouped together for each interval. Generally speaking, we probably wouldn't use a grouped frequency table if we only had possible values from 1 to 10. We actually typically use a grouped frequency table when there are so many possible values that the frequency table would be too long and too cumbersome to be useful. Remember that the entire point of using tables and graphs is that we want to be able to see all this information really quickly and really efficiently. And so, for instance, if I had a frequency table, if I had 100 possible values, that would be really long, and I'm not going to be able to easily get this information and be able to see the patterns of the data. So I might want to group those numbers, and maybe I would use an interval of 5 or 10 to kind of condense that information if I had a frequency table with 100 possible values. So again, a grouped frequency table would be a much better choice in that case. And so this is the benefit. We can present information quickly in a more understandable way. The drawback, on the other hand, is that in a grouped frequency table, we lose some information. So for instance, we don't know if we're using these intervals here on this slide. We don't know how many scores were a number 1 or a number 2. We only see the number of scores that were either 1 or 2. And so we lose a little bit of information about the individual frequencies for each individual value. We can only see them within the interval. And so we only want to use this really when there are too many possible values that it's going to make it difficult to use. And this is our frequency tables. And so this is an example of what that would look like. And so again, we see that we have our rating, our frequency, our percentage, just as an example here. And so it's going to look exactly the same. We're just using these intervals instead of individual score values.